Okay, all right, guys. Okay, we're gonna work now. I would like to get started working on matrix indexes. So one cool feature of Matlab is that we can manipulate every number of the matrix by addressing it with its index. So index will be like the row and the column. The way Matlab addresses the indexes is starting by 1. It doesn't start in 0 like Visual Studio or other languages. So, okay, for that, I'm going to create a matrix. Here in an example. Okay, so she told us how to do a matrix, how to declare a variable. So I'm going to call this variable. Oh no, she already has an age. I'm going to clear what she did. Clear all. You'll see. Okay, so now we have everything clean. So I'm going to declare a matrix, call it age. We're using square brackets, and we are using, for every row we separate by space. For example, 1, 2, 3, and to go to the next row we add a semicolon, and that brings us to the next row. So I'm just doing this as an example, right? Okay, so if I run this, well, this is already in the command window, so that's how it shows. Now I would like to go or manipulate one specific number from this matrix. So what I do is say that I want to go to the second row and the second column. That will be that number 5, right? So I can get to that number using age parenthesis, and whatever I put first, that will be my row. So I'm going to put 2. That will be my second row, comma, and now whatever I put in the second space, it will be my column. So I'm going to use column 2. So when I click enter, it brings up the number 5, which is in that address. So this, you can use it also as a tool. Say that you want to create another variable out of that matrix age. So say that the matrix A will be just the first row, the first column of the matrix age. So we can do this saying that A equals age, and then the column means that we're using all what is in that position. So if I put it first, I'm saying that I'm taking all the rows. If I put it in the second place, I'm saying that I'm taking all the columns. So put that in the first place, that it's taking all the rows, and then the first column, or the column that I want to take. So I should take the numbers 1, 4, 7, and 7. There it is. So it is taking all the rows and the column 1, and it's placing that into the new variable called age. I'm sorry. Okay, so we can use this also as a tool to create intervals. Say that I want the rows from the first to the third one. I want row from 1 to 3. So I'm going to call a new variable b, and I'm going to say that b is going to be equal of, from the first row, number 1, the column, and up to which row I want it. So I want it up to row 3, then comma, and what column. Do I want all the columns? Column 1, column 2, column 3. So I'm going to use from column 1 to column 3. 1, column, and 3. And there it is. So it's leaving out the last row, the 4th row, right? Okay, so you can use this also to do operations. Like you can say that the first element in matrix B multiplies the third element of matrix A. So you're pretty much using the matrix as a container to place numbers, data. Alright, so having that said, okay, we're going to do this example. Matlab has some built-in data. For example, if you type the function titanium, it will pop up this. It's actually like a two rows matrix. It has 49 columns. So I'm going to transpose that. I'm going to say x and y equals titanium. I'm going to transpose it. So y equals titanium. So I can read x and I can read y. It's right there. So I'm going to transpose x. So x, I'm going to say it's the x that I already have transposed. So that way I have it nice in only one column. And y equals y transposed. So now x and y are columns and are not those 49 columns that I used to have before. So we're going to write a text file. We're going to
go back
okay.
To your xy command where you allocate and transpose that menu.
Okay. Where do I allocate it?
So I have maybe the brackets that I have are wrong.
Okay.
Pretty much I have square bracket x comma y
okay.
square bracket
equals titanium.
Titanium.
Okay. No, don't use the don't transpose there. Yeah. Yes. All right. Is it cool now? Okay, good. So now we want to write this. Say we want to write this data in a text file outside, right? So what we're going to do is let me go to my script actually, because now I need to code, and I'm going to create a new script. Right. This one. That's the one. Okay, so right here. Okay, so the statement starts like this. I'm going to call f1, and what I'm doing there is that this is how the command goes. You type fopen. So what it creates is like a space where I'm going to put all the information and then write it in a file. So the name of the file goes right after this statement. So I'm going to call it data.txt, right? We end that. And then what type of permission are we giving to that? So if we're writing or we are reading, so we're going to write. So that's a W. So close that. And there we are. Okay, so now we already have the variables x and y as our data from titanium. So it has this function only for the titanium, and it's just for this reason, like when you're teaching, so you can use that data to support you. So now say that we want to write x and y to this new text file that we just created. So we want to put that into a loop because we want to go row by row and write every row into that new data file. So the way we do this is if we know the number of rows that we have, then we can count, like we can go from row 1 to 49. So this statement for I, this is how you use the for loop. For I equals 1 up to, now this statement, the length, what it does is it calculates which one is the biggest dimension of the matrix, and that's the one that it takes as the length. So we'll take the length of x, for example. So it's going from I equals 1 from the first row up to the length of x. If x equals 49, it will take from I equals 1 up to 49. So we end that. Okay, and then to print the values into the new matrix, the new data file, I'm sorry, we use the statement fprintf. So, yes sir?
You don't need to give the steps.
Okay, that's another thing. If you don't give the steps, Matlab automatically will take it in steps of 1. If you want to give the steps, you put another semicolon and you put the t here and say or 2. So it will go in increases of 2. But automatically Matlab will take it as in steps of 1. Okay, that was a good question. All right, so you can go backwards. Yes. Okay, so fprintf I'm sorry. And then you type here the name of the variable where you are storing this. So in our case will be our f1. Okay. And then okay, I should have gone over this, and I'm going to go over this in just a minute. But to express the variables that you're printing, you start with the %sign, and then the number that you are reserving, like the space, the total space that you're reserving for your number that it's printing. So in this case, I'm just putting 5 as any number, but it can be 10, for example. Dot 3. So what I'm doing is I'm taking a space of 10, and then out of that 10, 3 of those are going to be my floating point. So my decimals. I'm accepting. So copy that again. So we're printing x and y, right? And the variables that we are printing in there. By the way, this statement \n, that goes to the next row, that jumps up to the next row, and we're printing x and y, right? Okay, the x of I and the y of I. So because remember that x, it's actually a vector, and it has 49 numbers. So when I do the I, it takes, if I equals 1, it will go to the first element of x. If I equals 2, it will go to the second element. So that's how I'm printing the x and the y one by one into the new text file. So if we run this, hopefully it won't explode. Give the name, and this is, I'm gonna call it xy. Save. So now if we go to the workspace, I don't see it here. Okay, if we go to the folder where we are saving this, we should be able to see the new file that was created. It actually shows in the, like, next to the window on the left corner, there should be a box showing all the files. I don't know why it's not showing it here, but here, intro to Matlab, and we call that, did we call it data? Yeah, so here it is. So that's our data, and it's printed like that. Okay, let me see if it.
Yeah, it seems, because mine's formatted the right way.
Yeah, it's formatted the right way. Okay, let's reduce this number. It's probably too big. Go again. Okay, I think I know what it is. Let me. It's fine. What were you saying, Travis?
I wonder if it might just be because of Notepad. But like when I open up that data, that file in Matlab,
it pops up the same way.
right way.
It is the same way. Is the right way? Okay. Yeah, it's probably Notepad then. Okay, that's good to know. So Travis, he just opened the file in the Matlab, in the same Matlab program, and it's coming up the right way. So it's probably an issue with the Notepad. Okay, so we're doing that, and let me see what else I have here to show you. Okay, talk about the loop. Okay, so now let's we can manipulate that data as I show you. Okay, there is another. Okay, we just created that file. Now let's say that we already had that text file, and now what we want to do is actually load it. So you can do that this way. You have to create a name for the matrix where you want to put the data that you're reading. So I'm calling in this case data. And then load. The statement is load. And then the name of the file, which was for us data.txt, and I'm working on the wrong place. So sorry about that, I was working on the command window. So data equals data.txt. I'm gonna load this. Okay, so if you can also do this, you can copy from your script, go to the workspace, paste it, and it will run it. So it creates, I should have a matrix of data. That's what it read from my data file, right? From the txt we just created. Now I have a variable called data that takes the two columns of data that I already have and places it in only one array. So doing the indexes, you can manipulate this data and say that you actually want to plot that and see how it looks. So the statement will be something like the x will be equal to the data of all the rows and column 1, and the y will be equal to the data of all the rows and column 2, right? So what I'm doing there is separating, splitting the columns and putting them into different variables. If I run that, now I have capital X and capital Y, and I just type plot capital X and Y, and you will come up with something like this, which is whatever the titanium data that they read for that is. If you type help titanium, it will give you more information about this data.
Do you mind going back to your script for a minute?
Sure. Okay, so let me just go here to see what is my next topic. Okay, I was gonna talk about the loops also, right? So we already mentioned the for loop, and as in any coding language, you can have like nested for loops, like one for loop inside of another one. Notice that you don't have to do that statement where you usually have to increment the I. It does it by itself. You have to say like I equals I plus 1. Does it by itself. So the other loop is the if loop, right? So say we are saying if, okay, this statement is empty. It tells you if the array, if there is the array that you put inside of this, it's empty. It returns 1 if it is true, and it returns 0 if it is false. So if x is empty equals 0, so if that statement is false, do something. So I don't know, print. This is another feature of Matlab. You can use disp, which displays, is like a shortest version of the fprintf statement, and what it does is it displays whatever you have inside of the brackets, but the fprintf statement has like more flexibility when it comes to printing. Display x, it will display the matrix x right as it is. So display x is not empty, right? and we terminate the statement. So that's the if statement. Now we can put also another condition, like if it is not empty, print this, but if it is empty, print something else. So in that case we wouldn't put this. Let me run this so you can see how it will look. Go real quick. So it prints x is not empty, right? Because we already have something stored in variable x. So now say that if it is in fact empty, we want to say something else. So x to display x is empty, and we end the statement. Of course, in this moment it won't do this because in fact we have something in x. But we have that. So another feature is we also have the else if statement. An else if statement, what it does, it evaluates another condition. So I can say here else if, let's put here for example k equals 3. So now I'm going to change this a little bit. I'm gonna say if k equals 3, do this. But if k equals 4, do this. K is equal to 3, and here k is equal to 4. Okay, and that way I end the statement. So you will use this if you have like multiple possibilities. Like in the other case we only had 0 and 1, so an else statement was enough for that. So if I have this, do this, otherwise do the other thing. But in this case, since k is like a scalar, we can have multiple possibilities. So if k equals 3, display that. If k equals 4, display the other thing. So I'm going to put here k equals 4 to see how the else if works. And then I run this side of the script, enter, and then it went to the else if statement, right? And said k equals to 4 because we have that defined inside of the else if statement, right? So it skipped the first side and it went to, and you can have as many as you need. You can have 5, 6, 7. Now say that you actually want the user to define the value of k. So you can use k, you can type k equals input, and was it like that?
Mm-hmm.
Yeah. K equals input. Okay, and then please insert the value of k. So see, it makes everything a little bit shorter, right? Because you put the prompt for the user, and you at the same time it places the value that the user enters in the variable k. So we're going to run this side of the script. So it says please insert the value of k. So k equals 4. If I type another number, I'm going to break the code, so I should put like an else statement. K is equal to 4. So if I put an else here, this k has to be 3 or 4. So this way, else if it is 3 it will do this, if it is 4 it will do this, and if it is any other number it will do this. if we don't do that statement, that will break the code because Matlab wouldn't know what to do with that number. So please insert the number of k. So I'm going to put 10, and it should say k has to be 3 or 4, right? Okay, so that was if, else, if, and if else statements. Okay, let's talk about while loops. So while loop, what it basically does is just it evaluates a condition, and as long as that condition is true, it goes into the loop and it does whatever you define to be done during that time. So say while k is less or equal to 10, let's say, I'm going to print the value of k, fprintf, and that is just going to print the value of k. So the way I start, it's the quotation mark, %, number of that I am reserving for the value, floating point, type of variable, which is a floating point variable, and I'm sorry, this will be an integer. So for integer we use d, right? And then we are printing k. Okay, and then inside of the while loop won't do the same thing that the if statement was doing, of increasing the for statement was doing, that which was to increase the I by itself. So here we have to add a statement where we actually increase the value of k, otherwise we will be in an infinite loop. So okay, do this. Oh, by the way, you want to put a \n, so it will go to the next line and won't print everything together. Okay, so k equals 1. Run that again. Okay, this is another thing. Matlab has like a command history which you can access using the app row. See that it comes up under, like, in the lower, at the end of the command window. It shows all the commands that I have been using so far, so I can run all of them instead of typing it. Okay, so k equals 1, and I am going to paste this in here, and so k started being 1, it added 1, and it kept printing the statement that we have inside of the while loop, right? Okay, are there any questions so far? No? We're good? Okay, good. So okay, we're going to talk now. I would like to show you how to do user-defined functions. Right? So the way you do a user-defined function, you have to create a separate script for it. So go to a new script and you start typing function. And then you want to put a variable, which this variable actually doesn't matter whatever you call it, because it won't be reflected in your main code. So you do a user-defined function when you know that you will be executing multiple times one routine of code, and you don't want to type that multiple times into the main code, so you can call that function whenever you need it. So you say f equals, and now how are you going to invoke that function? Say distance, let's say, and this function is going to calculate the distance between two. Matlab already has a function called distance, so it cannot be. Call it dist 2 points. I'm pretty sure it doesn't have one like this. Okay, so this function is going to calculate the distance between two points. So now in the parentheses you're going to put what variables does your function need to perform its duty, its routine. So it needs x and y, right? And now whatever you put in the in your comments, that's what's going to come up when you type help, dist 2 points, it will pop up your comments. So this function calculates the distance between 2 points, right? Okay, so to calculate the distance between 2 points, we know that it is the square root. So now you call this the same f that you were using at the beginning here when you define your function. So f is going to be equal to the square root sqrt of the last coordinate minus the initial coordinate, right? So that would be x of 2. So x, we are assuming already that x should be a vector, right? Or you can call it, you can add more variables here, say x1, y1. This, I think this will make it simpler to understand, and x2 and y2.
Jose,
Yes, sir.
so we don't have to declare pipes, anything like that, if we want to be.
No.
And that's because every variable in Matlab is a vector by default.
Yeah, every variable in Matlab by default is a vector. Like, it's treated that way. Actually, when you want to do operations that are not vector wise, like something, you have to use the element by element that Armani was showing earlier, so that you tell Matlab, hey, I don't want you to treat this as a vector, I want to treat it as just numbers that are multiplied by those numbers. So okay, so f is going to be the square root of x2 minus x1 square plus y2 minus y1 square, right? Yes, but whenever you need to call this function from the main code, this is how you're going to call it. You're going to use dist 2 points.
So when you
It's
save
too long.
it, you save that function script as this under dash points. Right?
Yes. If you don't put anything here, because what this is doing is just saying, okay, f is the distance of point, and it's going to require these variables. What you do here is you say what actually f is doing. So f is going to do this. So you need to. So you have to say, okay, when I call this function, what is it going to do? Okay, well, that function is going to do this. Okay. F equals print. No. Yes. Yeah. Exactly. Yeah. If you want your function to display something, but Matlab already has that. So yeah, you will have to define a new way to call it that Matlab doesn't have it. Like, it cannot be DISP or display because Matlab has both. And then inside of your statement, you will end up writing the Matlab statement for displaying a function. So you will have, again, f equals disp, that, but now it's your own function, you're calling it a different way. So you have to save this, and you cannot change the name. Like this name that Matlab is giving here, dist underscore point, that's the same way I am calling that function, so you cannot change that because otherwise Matlab wouldn't know what to do with its life. F equals sqrt. Okay, I'm missing a parenthesis here. That's the error that it was giving me. Okay, so save that. And every time you do a modification here, you have to save again because it updates only when you save it. So now you can go to your main, like for example, your command window, and say our function was this points, right? Let's see, what's the name again? Was it with S? Yes. points. And then we have to fit it. See how Matlab helps us? It starts telling us the number of variables that we need to fit to this function. So x1 equals 0, y1 equals 0, x2 equals 5, and y2 equals 9. So that's the distance between those 2 points. Okay, so I went over user-defined functions. Okay, sometimes it is not necessarily like you want to do a user-defined function when your function is too complicated to put it in a statement inside of Matlab. Otherwise, you can use what Matlab calls an anonymous function, or like this type of statement. You can have this inside of your main code, and then every time you need to call this function, you just call it by the F1. But you don't have to create a separate script. You can do it in the same main function. So to do that, and I'm gonna work on this same example. So you declare the way that you want your function to be called. In this case, I call it function 1, F1, equals at. That's telling it that this is an anonymous function. And then in parentheses, you put the number of variables that you will be like the variables that you will be using. So in this case, my variable is t. You can have functions of multiple variables in here. So parentheses t, and then t will be equal to t squared plus 36 plus t over 2, right? So every time I need to call that function, I can just call it f1. We are running out of time, so but I'm going to go real quick over this last statement, which could be very useful, and it's the quad function. So what the quad function does is it integrates numerically. It uses Simpson to perform an integration. So let me use that same function. I'm going to integrate that. You work on another script. So say f1 equals let's make up a function. Okay, at first, at the variables I'm using x, let's say, and my function is going to be x squared. See that I am using element by element. That's how you need to define it. Every time you put a dot before an operation, I'm saying that it is element by element. So even though x is not an array, x is just a variable, I have to declare it this way. X squared plus 3x plus 5. Yeah, and it won't find a vector x, and exactly. So 3x, that's a mistake right there. So I have to put the star that way. So that's my anonymous function. Okay. So now if you want to integrate that function, you use the quad statement. So that integral will be the area. Area equals quad. It uses the Simpson rule to integrate it. And now it's asking for the function. So the function will be f1. Already mentioned that on top. And then the limit of integration. I want the function to go from 0 all the way up to 10, let's say. So it will give me the area of that parabola, I think, between the limits from 0 to 10. Here, go to the workspace, paste it, and then if I type area, that's my area right there. Okay, so are there any other questions so far? Okay, Matlab has a lot of built-in functions. Like it has ODE45, for example, is to perform differential equations, and there is, what's that? Yeah, it has. I mean, it's very powerful. So I encourage you to explore Matlab more, to look up more information, and I hope you enjoy the tutorial. Okay, that's it. Thank you guys.